Interrupt. Chain rule. New and more. Okay? You've been using, for what it's worth, Patrick JMT, www.patrickjmt.com, has lots of good math tutorials. I haven't looked at every one. That's from students in university that give me the thumbs up, so I'll leave that there. The idea behind the chain rule is you start on the outside and you work your way inwards. I got good at the chain rule by talking to myself. I swear to you, you thought it was just me. And I'm going to often use from physics, my DFIC approach, where I'll often list data, write things out, and go very, very systematically. Here's an example. Okay? This we would consider, a C++ level chain rule question. How do I know it's a chain rule? Because there's something inside and something outside. The outside function is to the fifth. The inside function is that thing. How does the chain rule work? Here's how it goes. You start on the outside. What's the outer mathy, functiony thing going on? To the fifth. And I'm going to do that rule. Now that rule says you move the exponent to the front. Leave a gap for me for just a second. And you subtract 1 from the exponent. Now the rule has always been, although you never realized it, it was always, and then you rewrite what was inside the exponent. When you took the derivative of 6x cubed, really what you were doing was moving this to the front, getting the 18, subtracting 1, and then you were rewriting what was inside the bracket. It's just that what was inside the bracket happened to be just an x all by itself. Okay? Then you multiply by the derivative of what's inside the bracket. Now here's what I found helped me. Look up for a second. On the original question, I always wrote it out. And as I did each function's derivative, I crossed it out. I would have gone like that. I've taken care of to the fifth. Now I'm taking the derivative of x cubed plus 3. And now we're at the stage where this part I can do in my head. What's the derivative of x cubed plus 3? By the way, let's go back to this really, really easy one. You were doing the chain rule without realizing it. You were moving the exponent to the front, subtracting 1, rewriting what's inside, and then you were multiplying by the derivative of what's inside. It's just, what's the derivative of x? 1, which you just missed my punchline. It's called an attention span. I need you here.
Sorry.
We're going to try this again. You were doing the chain rule all along. Can we do a favor? Shut that door for me right now. Could you do it, please? And Zach, can you shut that door for me right now? Hang on. It's not like the video is rolling or anything. Come on, get in here. I don't care. So when you did the derivative, you moved the exponent to the front, subtracted 1. You did rewrite what was inside. It's just you didn't think you were doing that because you just said, oh, put the x there. And then you were also multiplying by the derivative of what was left inside. It's just, what's the derivative of x? 1. So there is an invisible times 1 there. The chain rule has been there all along. You just didn't realize it because the chain rule results were negligible. Let's do another one. It's okay.
Is there a difference between dy over dx and dx over dy?
Yep.
Okay, so
Can I come back to that later?
Yeah.
Because that's a more in-depth question than you realize. Okay? Let's try this one here. Oh, heck, let's kick it up a notch. Let's try this one here, number 4. If I take the derivative I always find, and I can print this up for you later if you want, or you can write these down. I always find it easier to write out the original function. I just did here. Y prime, what's the outer function, Hannah? It's going to be move the exponent, subtract 1 from the exponent, rewrite what was inside the exponent. And I talked to myself this way to get through it. Times the derivative of what's left inside. What's left inside, and I crossed out that 4 to remind myself I've taken care of it. The derivative of 5x squared plus 3. Now, for both of these answers, they would not leave it like this. This first answer, almost certainly Nevada, they would take that 3 and that 5, and they would make that a. And they would probably put the x squared in the front, and then they would tack on the x cubed plus 3 to the 4th. So part of this is after you've done the derivative rules, you often have to do some simplifying. What I don't like about that textbook is I could never figure out what its simplifying rules were. For this one here, going around behind me, sorry. For this one here, it would be a 40, an x, and a 5x squared plus 3 all cubed. Let me pause the video for a second. We can combine the chain rule with all the other rules. I know I haven't answered your dx, dy, dy, dx question. That's a more involved question, and we'll get to that. You want me to try them? Okay, if you want to give me one. Okay. Like that? Okay. Then what I'd like you to do, and yeah, I'm looking at you, is watch the whole thing without writing anything down and then copy it out. Put your pencil down. It's not sine squared x. Yes, it is. No, it's not. Here's what it really is. It's y equals something squared. That's what it is. Something squared. How would you take the derivative of that right-hand function? You would go like this. Move the 2 to the front. You would subtract 1 from the exponent. You probably would never put the 1 there, but I'll put it there. You would rewrite what was inside, and then you would multiply by the derivative of what's inside. That's the pattern. That's the chain rule. Now let's apply it specifically to, by the way, that's what the chain rule is. It's take the derivative of the outer function, rewrite what was inside, times the derivative of what was inside. Oh, and if there's another inner function, repeat. Oh, and if there's another inner function, repeat. Oh, and if there's another inner function, repeat. But a lot of those, by that time, you're getting to the point where you can do that whole thing in your head. You don't realize, like I've already told you, that you've been doing the chain rule without knowing you're doing the chain rule. So, let's do this one. What's y prime going to be? The 2's going to end up there. Rewrite what's inside. Subtract 1 from the exponent. I'll put the 1 there because you guys will want to see it there, but I would never write it in real life. Times the derivative of what was inside. What was the inner function? What's the derivative of sine x? Now I'll get rid of that because that does irk me. Now, in Math 12, at the end of Math 12, you'll also know that 2 sine x cos x can be written differently. It's what we call an identity. It's the sine of 2 theta, I think, but we're not going to expect you to do that. It's just if you see weird answers for trig functions in the back of the book, there is some trig that you don't know yet that you will know at the end of the year that allow you to rewrite one trig function in terms of another trig function. Give me another one. Like that?
There's no brackets around the 4.
Yeah, I put it there anyways, because... Start in 1 second. Hang on. I don't see this. That's what I see. Something to the 4th. So I'm going to deal with that part first. How would I take the derivative of that? It would be move the exponent down. It's going to be subtract 1 from the exponent. Rewrite what's inside. Rewrite u. Now I'm going to move the 3 just a bit closer so it's not hanging in midair, because I can. That's taken care of. Now I'm going to multiply by the derivative of this. What's the derivative of 2? 0. Don't care. Going to ignore it. What's the derivative of cos squared bracket 4x? I'm not going to deal with that. I'm going to realize that that's the derivative of something squared. What's the derivative of something squared? 2 something to the 1 times the derivative of what's inside, u prime. Okay? So, running out of room, Mr. Dewitt, because you didn't plan this out very well. Don't you wish you could do that sometimes? Okay, so it's going to be, and I'm going to change colors so you can see that my thinking has changed. 2, subtract 1 from the exponent, there's going to be a 1. Rewrite what's inside, cos of 4x. And now I've taken care of that. Times the derivative of what's inside. Now what's left behind is cos 4x. No, it's not. What I'm going to deal with is cos u. What's the derivative of cos of something? Of something times the derivative of that something. That's the chain law. Negative sine, rewrite what's inside times the derivative of what was inside. So it's going to be negative sine, rewrite what's inside times, and I've taken care of the cos, and now I'm home free. I can do the derivative of what's inside in my head, because what's inside is 4x. What's the derivative of 4x? That's the chain law.
So, for the cos, like for the second derivative we have there in black,
I got to be careful because you said second derivative, which means something totally different.
okay.
But, okay, I know what you mean. Yep.
black ink.
So that was all that I took care of there was the squared.
So, okay.
Right? Ready? The exponent moves to the front. Rewrite what's inside. Subtract 1 from the exponent. Then we say times the derivative of what's inside. And what was inside was a cos 4x. That's where the green came from. What's the derivative of cos? Negative sine. Rewrite what's inside times the derivative of what's inside. And that's how I always talked myself through the chain rule. I talked it through in English. And you always would have heard me saying to myself, rewrite what's inside times the derivative of what's inside. Rewrite what, do the outer thing, and then rewrite what's inside times the derivative of what's inside. Yeah.
Simplifying that is hard.
No, it's easy. First of all, are there any plus signs outside of the brackets? So it's all being multiplied. So the coefficients, I see a 4, a 2, a negative, and a 4. Negative 16. Then there's going to be a cos 4x, a sine 4x, and a bracket. In any order, typically they would probably write it like this. Typically they would write the sine first, the cos next, and then the big ugly bracket tacked on at the end, probably. And that's just a convention. For some reason, sine comes before cos. Why? Because it just seems to. It does in the SOHCAHTOA thing too, for a purely arbitrary reason. No reason why it should, it just does. That there is probably an A- level derivative. Well, make it an A+ level. If you had one more non-polynomial function, like a square root or something like that.
Yeah.
Quotient rule, sort of. I'll change the numbers so you can still, or do you want me to actually do this so you know you're doing it right? Okay. This is number 5. Probably just chain rule. And again, by the way, if you're wondering in calculus, where do kids hit the wall? First wall, limits. They reach their limit on limits. No, I having taken calculus twice, I flunked it the first time. Having taken calculus twice, about 1/5 of the kids drop the course after limits, after that test in university. 1/5, maybe more of the kids drop the course after the chain rule. If you get through that, you've weathered most of the storm until you get to integrals, which will be in May. Okay? Give me 1 second. All right. Ready? This is not the question. Yeah, no, it's not. The question is this. Y equals u to the third. What would the derivative of that be? Well, the derivative of that would be 3u squared times whatever is derivative of what's inside the brackets. So my first step that I would write would be 3, rewrite what's inside the brackets, squared. I can't multiply the 3 in because of that squared. I would have to do the exponent first. Times the derivative of what's inside the brackets. Okay, what is inside the brackets? I'll change colors. Now that is a function that looks like this, u over v. Quotient rule. And I know the quotient rule says vu prime minus uv prime over v squared. Now, I suck at the quotient rule. I'm bad enough at the quotient rule that I would actually now say u equals x minus 1, v equals x plus 2, u prime equals, what's the derivative of x minus 1? Woohoo! V prime, what's the derivative of x plus 2? Woohoo! And I would actually plug and chug this in now. I would say, okay, v x plus 2 times 1 u prime. Am I going to bother writing the times 1? I say. Minus u times v prime, which is also 1, all over x plus 2 squared. Is that all right? And I've taken it all the way in. How do I know I've taken it all the way in? Because I reached the point where my derivatives were just ones, which, as I told you before, it was the chain rule without realizing you were doing the chain rule. Now, simplify. Here, it looks like I have an x minus x. What is x minus x? Don't overcomplicate this. What's x take away x? Woohoo! Then I have a positive 2. Ready? And I have a positive 2 minus minus 1. What's 2 minus minus 1? So, right now, I have a 3. I have an x minus 1 over x plus 2 all squared. I have a 3 and an x plus 2 all squared. The only thing that I would do after this is I can't help noticing, since this is times, 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 I got a 3 and I got a 3. It's a 9. Because this is on top. That's why you'll notice I didn't put the 3 down here. I know fractions. This is 3 over 1. I always remember as soon as I have one fraction, I want to write everything as fractions. So in my mind, I imagined a 3 over 1 just to make sure I could see what was on top and what was on the bottom. Good habits I've developed as a math nerd over the years. So my final answer, maybe, hang on, I forgot to put my prime there, by the way. I have a 9. Okay. I have an x minus 1 squared. And they probably, Cassidy would write it like this, x plus 2 to the 4th, because they would say you've got a squared in the bottom of the second fraction, and the first fraction also the bottom is squared, and they're all x plus 2s. There's really 4 of them. Is that what he has for an answer?
Sort of. I think you misread it the way I wrote it. I'm just my writing mistake.
Become.
There was a 5.
Oh, there was a to the 5th, and I put a cubed there?
Yes, my writing is just off, but I understand.
No, it's easy to fix.
Sorry.
Question?
Scroll down for a second.
So you ready?
For the
Ready? I'll walk you through everything. 9?
Yeah.
This squared would go on that as a bracket and on that as a bracket. So it's an x plus 2 squared and another x plus 2 squared. That's an x plus 2 to the 4th.
Yeah.
Okay. Now, apparently I did this wrong because you guys had a 5 there. For an exercise, we could track, okay, we get a 5 there and a 4 there, a 4. It would give us a bit more gunk. So I did a different question, which I said I should have done anyways, because this way you can still try the homework on your own. This is the chain rule. Be systematic. If I was really clever, I would have also crossed that out when I took care of the cubed. And you feel free to do tricks like that so that you can kind of be systematic. And start on the outside, deal with that, then move in, deal with that, then move in, deal with that. If you're not comfortable, don't take any shortcuts. Although most of the time, once you get down to that final inner polynomial, that one you guys can all do in your sleep as a derivative. But again, I'm telling you, when you did that derivative, you were doing the chain rule without realizing you were doing the chain rule. Let's do something really ugly. Yeah, but I'll never do one with a square root, or a cube root, or a fourth root. I'll do a fourth root, which is the same thing. Okay? I won't ever do one like that. What? I'll show you what I mean. Cassidy, how will I rewrite this? Absolutely. I'm going to write it as negative 3x to the 4th minus 2 all to the 1/4. I'll never deal with a square root. Why would I? When I have a perfectly good power rule that I can turn it into. Now, here's what I see. Something to the 1/4. How would I take the derivative of this? Move the exponent to the front, and then subtract 1 from the exponent. Now, when you're subtracting 1, you're really subtracting 4 over 4. Or if it was 1/5, 5 over 5, or 6 over 6. So 1 over 4 minus 4 over 4 gives me negative 3 over 4. Let me pause the video for a second. Aw, cute. Okay, hang on, we're going to pause the video again, because apparently I need to look at a little picture. Ready? So Nevada, again, square root, I never deal with a square root, it's an exponent. So really what you're saying is do another one with an exponent. Okay, it's a fractional exponent. Suck it up. When you minus 1, you can do the common denominator in your head. So right now, I'm going to have this. I guess there's going to be a big 1/4. Now that I have fractions, I want to clearly be aware of what's on top and what's on the bottom. Rewrite what's inside. Subtract 1 from the exponent, and then it's going to be times the derivative of what's inside. I just took care of this part of the original function. What's left inside? Negative 3x to the 4th minus 2, which I'm betting you can all do the derivative of, even though it's technically a chain rule. That one you've gotten so good that you can do that chain rule in your head. What's the derivative of negative 3x to the 4th minus 2? Technically times the derivative of what's inside the 4th, which is just an x. It is technically times what. We just never bothered telling you that part of it, but you were always chain ruling. We can tidy this up a little bit. What number is sitting right there? What number is on the bottom? This is 12 divided by 4, negative 12 divided by 4. Almost certainly they would write this as a negative 3. There's also an x cubed kicking around. And then the other thing that they would target is this negative exponent. We don't like negative exponents. Wait a minute, I can make any negative exponent a positive exponent simply by I'm moving it to the bottom. What I actually would always teach my students in Math 10 was a negative exponent acts like an elevator. It causes the number to change levels in the fraction. If the negative exponent was on the bottom, goes to the top floor and becomes positive. If, in this case, the negative exponent was on the top floor, the term goes to the bottom and becomes positive.
Good morning, Pitt Middle Secondary. It is Thursday, February the 2nd. Here are your morning announcements.
Okay, that's your standard derivative with respect to taking the derivative of y with respect to x. If you want to take, you would need a function that looks like this. Then dx by dy, those are y's, would be 9y squared plus 5. Okay? That's a 5. Oh, I know. That's why you'll notice I hardly ever use 5s in my notes. Okay? That would be the derivative of x with respect to y. Now, the real question is, how would you do it for that function when you didn't have the y by itself? There's something called implicit differentiation, which you'll get to down the road, but it's not yet. Just started that? Yeah. Which is also the chain rule. Okay? You had a question. Oh, hang on, this is physics, so let me stop the video record. Sorry.